Florian Rappl is a solution architect from Germany who is specialized in the creation of scalable distributed web applications. He is almost exclusively working on micro front-end solutions. Florian is a long-time Microsoft MVP in the development tools area. And actually, the most interesting part for me is he's going to talk a little bit. So his talk is warp speed with web development with Astro. And the most important thing about this talk is island architecture. So get your heads around it, OK? Let's invite Flo to the stage with a round of applause. And I'm out of here.
Thank you. Quite a nice crowd today. I hope you're all doing well. Quick question before we start. Who here would say, I'm a web developer? I would say most. We will convert you during the talk, I hope. So today we will have a look at Astro. I think about myself, everything was already said. Maybe one more important detail. I'm working for a smaller company in the Munich region called Smarpiot. And yeah, anything else is on the slides, which is also on the video recording. So let's not get stuck here. But let's first ask the question, what is Astro all about? Well, if you look today at the landscape of available web frameworks, most of you potentially already have heard about things like Next.js or Next, or maybe even other meta frameworks, maybe without the meta, things like Angular, or just using React standalone. The big question is, how do we make these things really perform well? So how do we get the best out of the web application if it runs? So for instance, if we look at the Google Lighthouse score, how can we make it close to 100? And what do we need to do with the existing web frameworks? And it turns out it's quite often not so easy to get close to a perfect score. And this is where Astro comes in, and where Astro tries to fit into a certain space for especially content-heavy pages. So Astro claims to ship blazing fast websites. And this word blazing was used very often in the past, and it always meant we are really fast. So, okay, so it's really, really fast websites, great. And what Astro really aims to do is to be ideal for content-heavy web pages. So web pages that by default, let's say, don't use so much interactivity. By default, it's really about the content. Think, for instance, about your shop system. Think about a thing like Wikipedia, documentation pages, things like that. But of course, it doesn't mean that Astro is not meant for interactive websites, and we'll come to that point in a second. Now, really importantly, by default, Astro ships 0 JavaScript. By default, so that's the baseline. That's not the goal at the end of the day, as mentioned, but that's by default. Let that sink in, I know. It's two numbers we need to know in IT. It's 0 and 1, and sometimes the 0 is not so important, but in this case, the 0 is really important, because this is what Astro is really all about. And if we want to compare, let's say, Astro to other frameworks, you can use, for instance, now the Google Lighthouse score. And what is shown here is a desktop view across, let's say, a couple of selected applications or websites. And what you can see is, if you compare Astro to, let's say, the same application written in other frameworks, like who here still knows Gatsby, but let's say Gatsby is just something similar to Next.js, so React-based. But many people also know things like, for instance, WordPress, or I already mentioned Nuxt. The difference is quite significant. So Astro turns out to be a quite good choice, and they actually have on their website the Google Lighthouse score that is, let's say, evaluated across all websites over the internet, where, of course, the information, what framework was used, is publicly available. And even there, Astro, of course, not with such a high score, but still with the highest score of all the frameworks, dominates the market. The big question is, okay, so that's Astro. But how can we write it? How can we also achieve really fast performance just by going to Astro or by utilizing it? And the first thing, and we will see a lot of live demos afterwards, is if you start an Astro project, the structure you get is not so different maybe from the ones that you know. So as an example, you have a directory which directly relates to your outputs, where you can say, hey, I got a file, don't tamper with it, just use it, bring it over to the output, I want to copy it later on to my web server or whatever, and that's called the public folder, that's just copied over. So all good? Well, nothing blazing about it, right? And then you have a source folder, so this is where your source code lives, and what you might have already guessed, since you saw, I don't really see my pointer here, a package JSON, so Astro is based on JavaScript or Node.js. So this is a thing like, for instance, Next.js. You spawn a new project using npm init, and then you can install Astro, and there you go. So far, no surprises, but now the big question is, what's all in the source folder? And there are many things. You can structure it, for the most part, as you like, but then you got certain conventions. For instance, there is a special folder called Pages, and the Pages folder has something that is, well, not so uncommon these days. Actually, most frameworks use that, and that's called file-based routing. So you create your structure as you want to have it later on available on your web server already in this folder. For example, if you have a file called index.astro, that directly leads to the slash. So since it's directly in Pages, that's the root slash. Or if you have a subfolder posts here, then you can have a special file which uses the square brackets to indicate a parameter. So now if you go to a route like /post/foo, that parameter for post would be filled with the string foo. Very nice, right? Or a file about Astro that will lead to /about. So what you write here in your local file system already has some relevance for the structure that you find later when your web server is running. You also got files that have JS or TS ending. These will be standard REST endpoints. So if you don't want just something that spits out HTML page, but something where you have, I don't know, verbs like a get or a post, then you can have a JS file, and then you can export certain functions, like a get function. And so you will now have a get endpoint that, in this case, corresponds to /rss.xml. I guess you would want to export some XML formatted content there, but yeah, whatever you want to do in there, it's up to you. What Astro provides to you is that you have now this convention-based, file-based routing. And that's quite nice. Otherwise, the structure that you see here with, for instance, components and maybe some content like the block here, that's completely up to you. You can navigate around it like you would do, for instance, in Next.js or the other frameworks. So imports would work the same. You also import resources to, for instance, your images here. And what Astro also does, by the way, is it optimizes these images. So it does not only, let's say, optimize the output regarding HTML for you, we'll come to that in a second, but it also optimizes resources that you are using, which is quite nice, and it's a cool feature of Astro in general. Anything that goes, let's say, beyond the standard configuration, you place in the Astro config, MJS, TS, JS, whatever you want to give it as a file extension file, and in there you write essentially what the behavior of Astro should be, if it should deviate from, let's say, a default behavior. All right, then one more thing that we need to look at before we go into live demos is how does such an Astro file look like? Because we get now a certain new file extension, so obviously there must be something special, right? It's not just a TypeScript or JavaScript file. And if we look at it, it has essentially two sections. So it has an upper part, and that looks a little bit like, for instance, a preamble that's YAML-based, for instance, in a Markdown file, and it's very similar. So the top part, that's already, in every case, evaluated at build time. It might contain instructions that are, let's say, usable not at a static time, but later on when a server is running, and then you would need to have special instructions, and we might come to that. But in general, this thing is already what's seen by the Astro build tool when you run an Astro build command, and it will say, oh, yeah, we got an Astro file, so let's see what this preamble is actually telling me. And what you can do in the Astro files, for instance, is you receive for your component or your page, you receive certain parameters, and you can, in the top section here, retrieve those parameters, or make some computations, whatever you want to do. You write essentially some TypeScript or JavaScript code at this preamble section. And then you got an HTML section, which is a little bit more than HTML because we already see special things. And I think here my pointer is not really working. But what you see is that you got these expression switches that you might already know from JSX, so from the JavaScript XML-based language extension. And using these switches with the curly braces here, you can then have some code that generate more HTML. But the nice thing about this JSX-like, let's say, syntax here is that it is not really JSX. It really also includes the rules of HTML. And one example here is, seen directly, an HTML comment, for instance. So HTML comments just work. They would be printed out like that or removed in a production build. That's all up to you. And so you got some kind of a synergy or meeting point here between JSX and standard HTML. Besides that, Astro also introduced a few, let's say, custom things. For instance, you see here astro.self, so you can reference your own component that you're at the moment writing, so you don't need to import your own component on the top again, because there's not a way to reference it, right? If you would import the same component in the component, that's like a cyclic thing, so not really good. The bundler would complain and it would tell you, what are you doing? I don't understand. And it doesn't have a name, right? So if you think about JSX or how you write React code, you always give them a name, so it's a fully legit JavaScript code, so you need to name your component, so you can just reference with the name. Here, I don't see a name, there's nothing. The way that something is named is by the file name. So this thing would be called nested list, and that's it. It's always the default export, and you just import it as a default import, so you can name it as you want to. Usually you would also name it like the file name, right? Nested list in this example. And that's how you would reference components and use them. In the usual case, and that's also the first examples that we look at, what we actually generate is really fully done at build time. So what you could say Astro is, at its heart, is a static site generator. So all you get is some static content and that's it. But I already mentioned these endpoints and things like that. So Astro can also be used in a mode where it doesn't pre-render and it actually gets active. And you can even make that selective, that only certain pages, for instance, are not pre-rendering. And they are really fully interactive and, for instance, fetching data on a server whenever the endpoint is hit. But we come to that in a second. Let's just remember for the moment that Astro is really blazing fast, but it only generates static sites. And we come to anything else later on. Now, so far, it's really fully static in two ways. On the one hand, we have the server way, so we just put HTML there, so nothing changes, it's good. And the other thing is, Astro ships 0 JavaScript, so it's also static on the client. That's maybe not what we want, right? Maybe we want some interactivity. And this is where the islands architecture comes in. The island architecture allows Astro to essentially lazy load JavaScript whenever it's needed. And the best part about it is that, in general, we don't have to really manage it. Astro does that for us. We only need to give it some hints. So how does that look in practice? Well, let's say this is our website, standard thing, right? So we have a header, a sidebar, content, footer, and maybe there's also some carousel, which is like an image slideshow, let's just say. But from practice, we know that this will be hardly static. For instance, it might be that in the header, we click somewhere and then we expect maybe something else to show up or hide or whatever, right? So a little bit of interactivity here. Nothing too fancy, just that it should work. Or the image carousel, that for sure requires some JavaScript. Sure, there are some CSS transitions and animations, and we can go a little bit further, but especially if you want to have some interactivity that we can say, hey, let's say there are some bullet points, you click on the second one and it should slide back, it should slide to the first, maybe it's even infinite or whatever. This will require JavaScript in general. So it cannot live without JavaScript. What can we do here? The first thing is we identify what parts are static and what parts require JavaScript. The second part is that we leverage now the islands architecture, which has two facets in Astro. The first is we give it a certain called directive. So when we introduce a component like our header component, for instance, we can say, hey, directive client load. Now what Astro will be doing is, it will look if there's any JavaScript needed for that, and it will also ship it to the client, but it will only ship that whenever the website is in the loading mode, which is fine because then we have JavaScript and yeah, it triggers off. So it doesn't seem so fancy, right? Because, well, load is like always. It loads in the beginning and that's it. So it gets much more interesting with another directive. We have the visible directive. So let's say our content is rather long. So the carousel is not shown immediately. Why would we need to load the JavaScript immediately? There is no reason for it, right? I mean, I'm sure it would already start sliding, but we wouldn't see the image anyway. So wouldn't it be much better just when we can see this image slider that it starts loading the JavaScript and gets interactive so that we can now click it, it now slides, it works essentially. That's what client visible is doing. We got also more directives. For instance, there's a client media, and we can say under certain media conditions, etc., etc. So there are a lot of useful directives, but those two will certainly be the most used ones. Client load, because we say, well, we always want the JavaScript to be there. Arguably, maybe even for the header, visible could make sense, but yeah, let's say it will always be there. So client load makes sense. And for something like the carousel, visible also makes sense because we don't know if it's always visible. We don't need to load the JavaScript if it's not visible. And the funny part about this island architecture is that it defines really, it gives you a boundary where it's really clearly defined that anything can essentially run in there. It doesn't need to be an Astro file because at the end of the day, an Astro file is really mostly interesting for static content, right? But this can now be a full JavaScript framework component. For instance, a React component. You can run in this island a full React component. So what Astro will do, it will load React for you and React DOM and whatever is required, and then it will load your component. And the interesting part is that when you have now two independent islands here, but they both require React, then of course this runtime would only be loaded once, right? So the first island that loads React, but then the second one only needs to load the component because the runtime is already there. So even though you can of course integrate what you want, Svelte, React, Vue, Angular, whatever, your custom framework if you want to, it of course makes most sense that also here try to stay coherent because that will have an impact of course at the end of the day on the user experience. You don't want to load 17 different frameworks for 17 different components, but you can. And Astro would make sure that even that gets as performant as possible, even though that will not be really so nicely performing. Great. Now, Astro has, of course, a very nice website where you can look at all the integrations that are there. And as mentioned, all the big ones are there, more exotic ones are there as well. So you can pick whatever you want to, or you could, of course, roll your own integration. That's all possible. One final thing before we come to the demos, and then we look really what Astro looks and feels like, is that there is a new, or rather new, I think it's already now, time passes fast, like 2 years old, there is a Vue transition API in the browser. The beautiful thing about Vue transitions is that it makes a multi-page application feel like a single-page application. So even though you have two different websites, but they still have the same header, so they have still, let's say, a common root, you can make it look like it loads in a transition so that it is a single-page application, even though behind you load two different HTML files, and both still starting at 0, essentially. And that's quite nice, because Astro allows you to opt into these Vue transitions by default. The browser API is not so complicated for that, but what is really nice about Astro, as mentioned, is that you need just, let's say, one line, and suddenly all your website feels even, let's say, more fluent than beforehand. It already felt fast, but now it also feels really fluent, and that's quite nice. So this demo that you see here, that's actually multiple pages that you have, but they just, this looks like a spa. Yes, it looks still a little bit shaky because it's a GIF, Yeah, you get the point here, right? So you got multi-pages, and it just feels like a single page. So quite nice. And with that being said, I like to go into the main part of the presentation, just want to show you how it looks like and how it feels like. All right, and if you have any question, by the way, always just ask them, because if we have them, we can also take them just in between. Great. All the code is available on the public GitHub repository, so if you want to have a look there, just check it out. And yeah. First thing I want to do, I hope that you can read it also in the back. If not, just raise your hand and we will increase the font size. So the first thing I'd like to do is just call npm create and call it with Astro latest. And what is happening, and I'm trying to make this a little bit larger, is that I get greeted by such a nice terminal UI. I'm essentially now become an astronaut, so very nice. And essentially it now tries to set up a new moon base. So okay, I try to call that sample. I hope I haven't given it another name. And then it even asks me what kind of template I want to use. There are more templates than the 4 ones shown here, but only the 4 ones shown here are, let's say, accessible directly now from this terminal UI. You can, however, place arguments when you call npm create Astro and yeah, choose one of the, I don't know how many there are, let's say hundreds of other templates that are there. So I, for now, want to go, I guess, with let's use the Starlight thingy. Or yeah, should we? Install dependencies. I try my luck. Let's see. And I'm already in a Git repository, so let's better not do this. And let's see how if the network speed is with me. It then sets up everything, the template is applied, and I get started with a little bit of code already that I don't start at 0. And when everything is there, I should be capable of just running it and showing you this one piece, and then we go over all the other things that are now in the repository. Okay, installed, great, that was rather fast, so great. Now I should be able to go into that directory and run dev. Great, so that worked. Behind the scene, Astro is using a bundler known as Vite, so Vite is rather fast, which is nice. And now I should be capable of just going in here and seeing the thing applied. So this is essentially Astro with the Starlight template, which is just an opinionated way of doing documentation. I mean, it describes itself. You can now go in there, and you should be capable of, for instance, updating the content. We can do that for 1 second. So here's our sample. You see it has some structure here already. It has a content folder, and in there is our index MDX. And now you're wondering MDX, but I thought we have Astro, and maybe we have something else. Well, Astro supports a lot of other things as well. As mentioned, it is for content-heavy websites. And so out of the box, it already supports MDX or just plain Markdown, which, of course, for content-heavy websites or even documentation websites, makes a lot of sense to support these things. You already see that here it really uses the YAML preamble. So all these things are a little bit written in here. And then you even see that inside our actual MDX code, sorry for not highlighting that, I would need to install the MDX extension to highlight it, but I hope you get the idea. You just write a little bit of JavaScript code like our imports, and that allows us to, for instance, use here the card component, right? Okay, and so I could just now make 2 exclamation marks. It should be sent out to the browser, and when I'm here, you now see, I make this a little bit larger, that we now got 2 exclamation marks. So essentially what we expected from a web framework in 2025, it still works. We got the hot module reload, and we can just start the development server and fiddle with the code. So quite nice. All right, so that's the basic template. Let's not, or the Starlight template. Let's try one thing maybe. So Astro said it is blazing fast. So let's try to quantify that. Just a word of caution, this is now run on the local host. I would always, of course, pick a real target site. I don't know where you want to host it and measure from there because you got additional latencies, etc. And so you get a much more realistic result, but just to get an indication. So let's analyze the page load here. And if we do that, we're like, okay. Hey, didn't it claim to have 100? But we get a 84. So there is something missing. Well, important piece, we are running the development server now. And I shortly mentioned that it's using Vite. And one thing I don't like about Vite, but that's actually a feature of it, but I don't like it, is that the development mode is a really different beast than what it is run later on. Because what it does in development mode is it doesn't bundle or anything. It tries to, well, it bundles some dependencies, but it never bundles your code. And it also, in this case, doesn't really produce HTML pages. Yes, of course, there's an HTML page, but most of the things that you get when we look at the network, let's see, I think I should have configured that correctly. I still have something here. Let me also make this larger. So, but we get a lot of files, right? So there's a lot of files, and it's 100, so almost 200 kilobytes transferred and 2.1 megabytes in resources, so that the transfer was just so low is, I didn't disable the cache, so most of the things are still from the memory cache. But it's almost 100 requests, and if we just, let's say, filter it to JavaScript, it's I mean, didn't it claim no JavaScript by default? But then again, this is the dev development server. And so Vite is doing something significantly different. So how can we make this more realistic also for comparison? What did I do? Press the wrong button. I hope I did really, did I stop it? Because otherwise it will be, okay, great. All right, so what we need to do is we need to run the preview mode, which is essentially just a plain web server, but the preview mode only works if we already generated the artifacts. So what we really need to do, wrong directory, is we need to run the build command, so npm run build. So that creates the artifacts that we could, for instance, put on our static storage server. And then we run the, I think it's called preview, the preview mode. So it's the same port. And now, if we do that, we still got some JavaScript, but that's now because of the template. But if you look at it, it's way less than beforehand, so really a lot less. And it also, I mean, the 2 megabyte resources, that's gone, right? It's now 191, and I guess most of it in the images. So let's try to run Lighthouse again. Okay, let's throw that away, and let's just try that again. And it should end up with a much better score, unless it's one of those days. Aha! So suddenly we are at 100. So this is quite good. This is what was promised. Again, this is not a final result. Measure at your own web server. But if you would here, let's say, be at 90, I would doubt that you get a better score at your own web server, right? So where we are a little bit more far away from the source of generation. Okay, this is great. So nice. So Astro seems, at least now on the surface, to deliver. Really good. Great. Now, let's close that for a second. And let's maybe go away from the sample. Let's go to the hello world. So what would you get if you have the standard template? There are no real surprises here. As mentioned, you got the Astro config. It's pretty much empty. Define config with nothing. You could actually drop it, and it is the same. So nothing here, but it was prepared that if you want to change it, then, well, you don't need to write the boilerplate that's written for you. Otherwise, as mentioned, there's the pages folder in the empty template. It's not really the empty template, but it's, let's say, reduced to the bare minimum. You got just the index Astro file. And here you can see essentially what we talked about. You got imports that are working as imports, for instance, in a JSX file. So you just import them with a reference to the file system. So one folder up into components, and then there seems to be a welcome Astro. So that's how you can, for instance, include a component that was written beforehand, and as you can see, that's just more or less a fragment of HTML, but with the important extension of allowing the expression switches as known from JSX, so you got your curly braces here. And suddenly you can reference images like the SVG that you got. And for instance, the SVG, that's really neat in Astro. It just doesn't import, let's say, the content of a file when you import images. It gives you an object, and this object has then certain properties, like for instance, if you want to reference the content of it, it has a certain property called data, I think. And if you want to have the reference to it, then you just use the source one. And for the SVG, it makes sense, I guess, to use source, because yes, you still need an extra request to load it, but then it can be cached, and yeah, you're good, right? Whenever anything can be cached, it's always good, because yeah, you just paid on the first time with the additional round trip, but on the second one, no round trip needed, all done for you through the browser's cache. Great. So this one works essentially like you would already know from React, just already with a little bit of these Astro optimizations in mind. Other than that, what is usually the structure is that you have a layout. So what you can see here is this welcome component is wrapped inside a layout. And layout is just, let's say, a special kind of component that brings, for instance, a head and all the, let's say, necessary structure to you. So here you see, for instance, it brings the doc type, the HTML, and the head, and it might then even use special things like a meta name for the generator. If you don't like it, just remove it. So the one question, of course, that might come up is, how do you now transport the children in? In React, that was done via a special prop called children, and here you just use slot. Slot you might know already from custom components and the shadow DOM. You can have a slot in there. Well, Astro uses the slot to just say, we got something where you can give me the children. This is an unnamed slot. Astro also supports named slots. So this is something that, for instance, React doesn't have out of the box. You would just use a different property and give it an arbitrary name. And in Astro, you can solve it already via named slots, and you have then children. So everything solved here. Now, moving on and also then running to the island architecture, it gets interesting. Because this was, let's say, the minimalistic template, but let's go one step further. And let me already start this example. So I think that's 0.2, and we run the dev mode again. So how does that look like? Let me close this here maybe. Or yeah, I think it will be interesting. So let's let it open. And also let me open the network tab. All right, so this is the page that is the official block template that Astro brings. And what I did to this simple page is I added one thing. It's tiny, but I'd like to, to highlight it. It's this button here. I try to click it, and it seems good. So we already incremented. Very nice. Everything seems to work. What did I do? Well, it's this template, right? So this template has an index page. And let me make this smaller a little bit. And on this page, yeah, a lot of static content, static, static, static. But then we got a component down here, counter, and here I use a directive, client load. First question would be, of course, where does this counter come from? Well, as we've seen, Astro does no magic, so we need an import. So somewhere must be specified, and we see it comes from components counter. Okay, so let's look there. Aha, this is different to the other files. We see it already here, it doesn't have a .astro, and we also see it in the file system. It is a .tsx file. So something with JSX in there, so something React, I guess. And the file also reveals it certainly has to do with React because it imports React, and then this is a standard counter component like you would see in a React 101. Now the big question is, we now know that there's this counter component, it's being used. What would happen, for instance, if we would just remove this client load, for instance? Let's just do that. Okay, so we remove it. Nothing is happening anymore. And by the way, this again is a little bit a bad view because we get already all these JavaScript output. But looking back, we wanted to start with 0 JavaScript. So let's maybe do the following. We still stick with the no directive, okay? Just for argument. We run build and preview. Sorry. So it builds, it runs the dev server. So now, if I just refresh, it was that fast, so sorry. This is the output. I don't see a JavaScript file, just to be sure. I go on JS, there's nothing. No JS, but the button renders. That's an important point. So I still get a button here. But the thing is, I got no JavaScript, and if I press the button, nothing is happening. I mean, I saw also on the dev server, nothing is happening. But now I also see in the network tab why nothing is happening. I don't get any JavaScript. Of course, I can now go back. I activate client load. I do the same thing. I build, I preview, just to show. And by the way, I want now to start at the top. We come to that in a second. I refresh. And what you see now is we get 3 new files in there. We got our counter component. It requires whatever client thing it is, but it is heavy, so I guess it is React. So that's React and React DOM, that's the runtime. And then we even got our little index thingy, so that's also related to the component. But the end result is that I now loaded JavaScript and I can make this button again work. So great, Astro works, it hydrates this thing, everything is awesome. Now let's do one more thing, just to fully bring the point over. We can make the client visible directive. If you remember, that is what is, for instance, best for the carousel component, because then only when it's shown, the JavaScript would be loaded. Okay, I run the same code. Let us start at the top again. And I also clear the network view, because what we should see is that it looks like we don't have any JavaScript. And I mean, at this point, we don't have any JavaScript. But then I scroll, and suddenly, when this thing enters the screen, all these files have entered the network tab, have been loaded, and the component is now hydrated, is live. So Astro makes sure that this thing really works as it should, but it also made sure that it already pre-rendered. That's an important piece, right? Because let's say most React applications that have been done for single-page applications, you know them because they start with a loading spinner. There was nothing there because first the JavaScript needs to bring over all these renderings. Now Astro, of course, being static first, it already tried to move it into a mode where it can just display. It's not interactive yet, but that's, of course, what the islands now can solve for us. So pretty neat. Looking if we have any questions. No questions? 2 questions. Should we? Then maybe let's take the questions right now, because otherwise I don't know if I can show something if they're really. Can we switch slide? Yes, please.
Okay. All right. In the introduction, it was said that you are into micro frontends. There are a lot of approaches to it: frames, web components, module federation, native federation, framework building, etc. Which use cases do you see for each, and how should a team decide which one to use? When it should be avoided?
It's a question where I can give whole talks about. I try to summarize it. I mean, the really short answer would be it depends, because it's really fully project specific. As an example, I mean, iframes, they have been around for a long time, and they tend to be good for micro frontends because, well, you really had this boundary to something completely unrelated. For instance, a company making advertisements, right? And they want to be on your website. They don't want that your styling or something affects the advertisement that is shown. So iframe is ideal for such a solution. Now, for internal micro frontends, iframes are usually not a good solution, and the reason is because it's anyway internal, and with the iframes, you would have a lot of duplicates. So everything would be duplicated, it's a completely new document. Then some of these other approaches make sense, and some of these that are mentioned, they are not exclusive. As an example, web components can always be a transport mechanism for micro frontends, whereas module federation is just a good way of sharing, for instance, dependencies. Native federation, module federation, even they can be combined, but usually those two things solve more of the same, let's say, kind of problem. Therefore, the decision what you use, again, it really depends because it's highly project specific. There is a good decision tree that was created by Luca Mesalira. I would recommend you to check that out. And for anything else, I would say let's just discuss afterwards because, again, this is a huge topic and that's what I do with most of my time. But yeah.
Okay, the next question is there a way to opt out of file-based routing? I find we often have to build more complicated routing on top of file-based routing systems and often could just do without it.
So there's no direct way to opt out, but there are, of course, indirect ways. So I've shown the parameter way, and there's also a slug way where you just say, I don't care what is in there, just give me anything that starts with it. It's like a star route if you have express-based routing and so on in mind. So that even sub-routes, they would go to this one route. So you could, of course, say, on the root level already, I want to opt out, so I use this kind of slug route, which is in square brackets and then dot dot in there. So you could use something like this as an example. But out of the box there, it's so baked into this convention that there is no way to just, roll out your own convention or something. But the question really sounds like you want to have full control. And then what I would recommend is having this, asterisk or wildcard-based routing where you say, I take the full path, you give it to me, and then I decide what I do with it. The big problem, however, and that's what I want to mention here is, if we are in this, and so far we are, and maybe we don't even can reach it, but there's a third example with the server-side rendering. And if you want to stay in the static side rendering, then having the wildcard is, of course, all these parameter-based routes have the problem that you need to tell Astro what parameters are available, so what are the values. Because otherwise, how can it generate for you websites, static websites, if it doesn't know what is the input, right? That would be dynamic then, because now you get a dynamic input and you react to it. So if you opt in for the wildcard-based routing, you usually also opt in for server-based or dynamics. And so therefore, some of the things that we've seen, they are not, let's say, outdated, but all the server-side parts of Astro, they come now on top of it.
Are there use cases where you do not recommend using Astro?
Yeah, of course, if your website is fully dynamic, and with fully dynamic, that could be meaning server, but here I would make an asterisk as well, because also Astro shines here. But if you say, it already starts with, I have a design component set that is full of React components, as an example. And I already know I want to create a single page application using React, then having, for instance, Astro is just something in the way. But if you have something either based on web components or plain CSS or something like that, where your design set is also very nicely compatible with the idea of having already a static site that just works, then Astro can work wonders. We usually use it for really small pages, that sounds like it's a contradiction to these content-heavy pages. With small, what I mean is domain-specific, really to one point. There might be still a lot of content behind it and everything, but it's not like we want to create the whole universe now in Astro, but we have one specific target. As an example, we use it for a meetup page, and now it has all the meetups and everything in there. We also use it for a conference page. This also has an admin part. The admin part was done with React longer ago already, and we were able to just hook it into nicely because of the island architecture. But then everything regarding the real contents of the conference page, that's super fast. It's built really fast, it works really fast, so it delivers. And so I would say it shines in scenarios where you're really to the point and something you can grasp. And anything really large, again, not from the content that you show, but rather from the use case that you have in mind, from development use case, it can still shine, but you need to think about how much the constraints also that come with Astro, so the opinions that are there, conflict with the ideas that you have for the long run.
Okay, these are all the questions so far. We are out of time.
We are out of time as well.
So thank you very much, Flo, for coming here and for having us. Thank you, guys. This is a small token of appreciation. Thank you so much.
Thanks.